Well, hello Year 8 and Year 7, welcome to your last lesson. Well done everybody who did all of those word equations and wrote those little essays in the last few ones. You've now looked at, this week you have looked at, let's think back, on Monday you looked at the dangers of acid. On Tuesday you looked at word equations and oxygen, so what happens when a metal reacts to oxygen. Yesterday you took it up a notch and you looked at what happens when they react with acids and water. Now today we're going to move on to something called the reactivity series in displacement reactions. Now there are two options of what you can do after I've explained what a displacement reaction is. So you have two options of the tasks that you can complete this lesson, depending on how confident you feel. So if we go to the first slide, you will see that I just want you to recap what you did yesterday. So here are some acids and here are some metals. Can you recap and can you remember what product you're going to make when they react together? Because that is going to really help you out in Year 9 and Year 10 and Year 11. So have a go at that, put your answers in the box and then move on to today's lesson. So I'm going to do a little bit of teaching for a few minutes now just so we can get the idea. The reactivity series of metals tells us how reactive a metal is in order. So if I put the reactivity series up, straight away you can see that right at the top are those metals that reacted really quickly and violently and vigorously with water. So there's potassium, sodium and calcium right at the top of the reactivity series. They'll also react with air and they will also react with acids. So they're really reactive. They'll just react with anything basically. So that is at the top of our reactivity series. As you go down, they get less reactive and less reactive and less reactive until you get to the bottom where you've got silver, gold and platinum. Now platinum will be chucked in acid and it will take years and years and years and years and years for anything to happen to that platinum. So that it's really unreactive. And when you think about it, what are your rings and necklaces and bracelets made out of? These kind of metals, because they don't react very much with oxygen, they don't react very much with water, and they don't react with acids. So they're right at the bottom of your reactivity series. So it just goes from the bottom, not very reactive, not very reactive, getting more reactive, getting more reactive, getting more reactive, bang. Okay? And the reason the reactivity series is important is, first off, it tells us what's going to happen in chemical reactions. So if I'm doing a reaction in the lab and I think I'm just going to chuck this big chunk of potassium into this acid, will all be fine. I can look at the reactivity series or you can go, Miss Hughes, that's not a good idea. And that's because it's right at the top of the reactivity series. It's going to react really vigorously. It's also important for building materials and things. It's no good making a pan out of sodium, which is what you were talked about yesterday. You're going to make it out of something far less reactive like lead or copper. I mean, it'd be great if we could have platinum pans, but I think they would be a bit expensive. So on the next page, we're going to look at something called a displacement reaction. And you're going to have to refer back to your lovely reactivity series to do this. So a displacement reaction is when and I'll just race it a little bit ahead because I do have a definition, is when a less reactive metal replaces a more reactive metal replaces a less reactive metal in a compound. So if something's more reactive and it's higher up the reactivity series and it sees a metal that is less reactive and it's got something it wants, the more reactive metal can basically kick it out and take what it has. So let's just go through that using my little examples here of Star Wars characters. So we've got Mr. Copper plus Mrs. Sulfate makes copper sulfate. So copper sulfate is a compound. So they go around together and they hold hands and they're in love and everything's cushy. And then along comes Mr. Iron. And if you go back to the reactivity series, because this is what you have to think about, iron is above copper. So it's above copper in the reactivity series. And what that actually means is iron can take whatever copper has. So iron comes along, says, I like the look of my sulfate, steals my sulfate, and poor Mr. Copper's left on his own. So there's the word equation, copper sulfate plus iron equals iron sulfate plus copper. And here it's asking you what do you think has happened in this reaction, and I've already explained that iron's more reactive, so it's come along and it's taken Mrs. Sulfate and left poor copper on its own. Let's look at another example. So you've got Mr. Magnesium with Mrs. Chloride here, so it's magnesium chloride. Along comes Mr. Sodium. Now Mr. Sodium is right at the top of the reactivity series. You have seen it being chucked in water and reacting really vigorously. So sodium can kick out magnesium and steal Miss Chloride. So there you go, Mr. Sodium and Mrs. Chloride are quite happy there, and Mr. Magnesium's left to go and find somebody new. Now, what do you think the products will be if you swapped them around? So if we swapped and it was Mr. Sodium with Miss Chloride and Mr. Magnesium came in, what do you think is going to happen? Nothing. There'll be no reaction. If there was sodium sulfate instead of magnesium sulfate and magnesium tried to steal sodium, going back to your reactivity series, there is no way that's going to happen because magnesium is less reactive than sodium and it can't kick it out. And that's all it is. It's looking at the reactivity series and saying which one is more reactive and is it who's going to win basically. So this sets up for your first task. And like I said, there are two options. This is why you need to watch these videos right to the end. You can either do the chloride cup, and what you have to imagine is that there are these football teams, and if you look on a few slides down, you'll see the football teams. What I suggest you do is you close your eyes and you point at your screen and you pick two football teams to have a match with each other, and I'll show you how that works. So you'll have this document, and I went and I've closed my eyes and I've touched the screen and I've got aluminium Albany or Albon, like people who watch football will be able to say that. And I picked Magnesium Town. So they're now going to go into the top part of my table because here are the two people. Here we go. If I have to use my mouse, here is the first match. So the first match, then you've got these lines. Who is the winner of the first match? And then two more teams can fight each other, so have a match with each other, and whoever wins goes here. And then these two will have a match, and whoever wins goes there. And it's just like a football league table. So aluminium goes in the top, and he has the chloride because he's the first one, and magnesium comes in. Magnesium is a lot more reactive than aluminium. If you go to your reactivity series, it's above it, which means it can kick aluminium out, and magnesium goes on to the next round. You will then pick another two, and then who wins goes on the next round. So I know some of you already know how to put text box in here, so you can do it that way, or you can write it on a piece of paper and take a photo and send it to me in the email, and I'll stick it in your PowerPoint if you're clever enough to do that, because sometimes Miss Hughes doesn't even know how to get a photo from Google. And that is how you'll build it up, and you'll get a winner. So in here you'll have a winner for your match, and it shouldn't take very long for you to do that. Now, if you think, oh, I don't understand, I'm going to struggle with that, the next thing you can actually do, and this is task 2, if you want to complete both, you can, but I'm not expecting you to complete both because this can take a little bit of time, is write me an explanation of what the reactivity series is, why it's important, and what displacement reactions are, with some examples. So in this box, I've kept a space for either you to put kind of equations from your football league table or to write the explanation. So I might start with the reactivity series is something that shows us the order of metals in how reactive they are. Please put that in much better English. And then I'll move on to talk about what a displacement reaction is and give some examples. I could draw some pictures. You might draw a little comic strip. Any way you want to show me that you can understand what the reactivity series is and kind of what is going to happen in a displacement reaction. But please have a go at this because it's quite fun. Some people might be like, oh, well, I already know who's going to win. That's okay. Maybe challenge someone at home to it as well. Maybe you say to them, right, I'm going to close my eyes. I've got aluminium. You close your eyes. You've got magnesium. Haha, I win. Next one, I've got this. I've got that. This one wins. It goes into this bit. And just have some fun with it. And that's all I really want you to do today because you have worked really hard in science this week and there's been a lot of new terms and a lot of new knowledge. And it's hard to do this module when I'm not at school. So have a go. If you need any help, remember to email or write in the little box that everyone writes in the private comment and I'll get back to you and I'll help you. So good luck with today's work, and remember you don't have any tomorrow for science, so you can leave this till tomorrow if you want to break today, and just have fun.